we already learned two-dimensional array, and with the help of two-dimensional array we did few matrix example where we take the input of matrix, print the matrix, create some transpose matrix, do some additions of matrix. But today we will learn matrix multiplications, which is bit complex compared to matrix additions. But if you understand the logic, then it will be easy to implement that matrix multiplications in Java. So today first we will try to understand and try to clear our concept how matrix multiplications work. And if you get the idea, then it will be easy to implement that logic in Eclipse for Java programming. So let's say you have two matrix, one is A and one is B, and you can see R1 and C1. This is basically row count and column count of first matrix A, and similarly R2 and C2 is row count and column count of matrix B. Now if you want to multiply A and B, okay, then you have to maintain some, or you have to understand some concept. And what is that concept? So I will give you three main concepts which you have to understand, you have to consider before doing any multiplications. So first thing is that the column count of first matrix, that is A, should be equal to row count of matrix B. If this is equal, that is basically C1 column count of first matrix and row count of second matrix. If these are equal, then only you can able to multiply two matrix, else it is not possible. So if I take example, so you can see here my column count, that is basically C1 column count in my first matrix is 1 and 2. This is my first column, this is my second column, so column count is 2. And in my second matrix, if it is a B matrix or my second matrix, so here the row count is 1 row and 2 row, that is basically 2 row. So my column count of first matrix and row count of second matrix both is equal to 2. That's mean both are same, and I can create a multiplications with these two matrix. Now if you take the second example, here you can see column count of first matrix is 2. This is 1 and this is 2. And row count of second matrix is also 2. Though the column count of second matrix is 3, we will not consider that one. We will only consider what is or how many number of rows available in second matrix, that is this is first row and this is second row. So R2 basically 2, that is basically row count of second matrix, and column of first matrix is also 2, so 2 2, that's match, so I can easily make a multiplications for these two matrix. Now if you take the third example, so here you can see the column count of first matrix is 2, but the row count of the second matrix is 1 2 3. So that's mean these are not same, one is 2 and another is 3, so C1 and R2 is not same. So in that case I'm not able to make a multiplications of these two matrix. So we have to consider this one before creating any matrix multiplications, maybe in normal traditional calculations in a pen and paper or in your Java programming. So this is the first considerations we have to consider, that column count of first matrix and row count of second matrix should be same. Now the second considerations we have to understand, that matrix multiplications and normal arithmetic multiplications both are not same. What I mean to say, so if you try to multiply 2 into 3, you get a result 6. Even if you change the order, that is basically 3 into 2, that is also come the same result, that is equal to 6. But if you have two matrices, let's say A and B, and if you try to multiply A into B, this is not same like B into A. So in matrix multiplications, order of matrix is very important. So this is my second considerations which you have to understand. Now the third understanding should be, what will be our row and column count of the result matrix. Result matrix means, let's say my first matrix is A and second matrix is B, and I am trying to multiply these two. So what will be my result one? So if result one matrix name is C, so you can see the row number or row count of the first matrix will be the row count of the result matrix, and column count of the second matrix will be the column count of result matrix. So the third step, you have to understand that whatever the row count available in your first matrix, that will be your row count in your result matrix, and whatever the column count available in your second matrix, that will be your column count in your result matrix. Okay, so if you understand these three, then it will help you to create or to implement a Java program in Eclipse. Now we have to understand how we can multiply two matrices. So you can see here, this is my first matrix, this is my second matrix, and the multiplication step I have given here with these four steps. So the matrix multiplications will be done like this way. Element of the ith row of the first matrix. So this is basically ith row. It can be 1, it can be 0. So that will be multiplied by element of the jth column in the second matrix. So column, basically this is column, this is column. So column 0, column 1, or we can say j is equal to 0 this one, or j is equal to 1 this one. So first we have to multiply, and then we have to add that products. Okay, and the summations value would be the, so whatever the product we sum, so the summations value would be the result matrix element, which positions of ith row and jth column. So if I try to multiply and make a additions of that product with row 0 and column 0, that's mean my ith positions is 0 and jth positions is 0. So result will be 0 0. So I is 0, j is 0, and 0 0 is nothing but this one. This is row 0 and column 0, 0 0, right? And how we can make additions of products, that is something like this: a1 with a2, you can see a1 a2, then plus b1 c2. So here you can see plus b1 c2. So ith row of first matrix, jth column of second matrix, I am doing some multiplications, and the product I am getting, that I am adding here, and finally whatever the result, that is basically calculated in the result matrix position, that is nothing but I and j combination, that is basically 0 and 0. Now this is my first step to get this value. Okay, now to get the second one, so column 1 of row 0, so 0 1, this is basically 0 1 positions. So do that. So you can see this is my second step, where row 0 or I is equal to 0, j is equal to 1, that is basically column 1. So second step we will try to do for these positions, and this is nothing but I0 means row 0 and column 1. So what is my row 0? This is my row 0 and this is my column 1. So we have to do some multiplications and additions of this row and this column. So here you can see A1 into B2. Here you can see A1 B2 plus B1 D2 plus B1 D2. So this one and this one multiplications, and finally with the product additions, and the exact result or the final result will be in position, that is basically I, it is basically 0, and column, that is j is nothing but here 1. So 0 1 positions we will get the value. Similarly in step 3 we will try to calculate the value for these positions. What is these positions? Row 1 and column 0 combination. So 1 and 0 combination. What is 1 and 0 combinations? Actually this is the positions on the result matrix, right? Because this is row 1 and this is column 0. So this is 1 0. And how we can do that? So here c1 a2, you can see c1 a2, then plus d1 c2 plus d1 c2. This is my third step. And fourth step is basically taking the value for these positions. What is these positions? This is basically row 1 and also this is the column 1. So 1 1 positions, I is equal to 1, j is equal to 1. So here 1 is basically ith positions 1, and column, this is basically jth positions is also 1. So if we multiply and then make a summation, so that will come here. So you can see c1 b2 plus D1 D2 D1 D2. So once I get this calculated value, that will be in this position, that is nothing but 1 positions, right? So if we maintain this fourth step, then we can easily calculate the result matrix value. Now take a simple example like this. So this is my first matrix and this is my second matrix, and I want to multiply these two. So how we can do that? So first positions is row 0 with column 0. So what is this 0 0? This is basically the positions, and how we can do that? So we have to multiply this with this. So row 0 and column 0. So 1 into 5, then 2 into 7, and additions of that 1 into 5 plus 2 into 7. Then row 0 column 1. So that is basically 0 and 1 position, and what is that? This is basically this one, row 0 column 1. And here you can see 1 into 6, then plus 2 into 8. So 1 into 6 plus 2 into 8. Now coming to the row 1, so row 1 will be first multiply with second matrix column 0. So 3 into 5 plus 4 into 7. So you can see 3 into 5 plus 4 into 7. Now the last one is basically row 1 and column 1. So this is my row 1 and this is my column 1, and how we can do the calculations? So 3 into 6, so you can see 3 into 6, then plus 4 into 8, because we are doing this row with this column. So 3 into 6 plus 4 into 8, and finally whatever the calculated value is coming, 1 into 5 plus 2 into 7, that is nothing but 19. Then this one is basically 22, then this one is basically 43, and this one is basically 50. So first matrix and second matrix multiplications result is something like this. So in our first example, we can see that the row count and column count of first and second matrix is same. This is basically 2 into 2, right? Now if you take this example, here you can see the row count of the first matrix is 2, where column count is 3, and for second matrix row count is 3 and column count is 2. Okay, now how we can do the multiplications? Process is same, only one multiplication step will be added here, extra multiplications, right? So if we take the first row with first column, or the zeroth row with zeroth column, then you can see here 1 into 10, then 2 into 20, then 3 into 30. So same thing I have written here, 1 into 10 plus 2 into 20 plus 3 into 30. This is basically row 0 and column 0. So this is the positions, row 0 and column 0. Now row 0 and column 1. Okay, row 0 and column 1, what is this? This is basically row 0 and column 1. And how we can do that? So 1 into 1, then 2 into 2, then 3 into 3. So 1 into 1 plus 2 into 2 plus 3 into 3. Okay, so this is basically row 0 and column 1 value. Okay, now row 1 and column 0. So this is basically my row 1 and column 0. So this orange one is 1 0, and how we can get 4 into 10, then 5 into 20, then 6 into 30, and their additions. Okay, so you can see 4 into 10 plus 5 into 20 plus 3 into 6 into 30. Now row 1 and column 1, so this is basically 1 positions in result matrix, and this is nothing but these positions, right? And how we can get the value? So 4 into 1, then plus 5 into 2, then plus 6 into 3. So we are doing the same thing, 4 into 1 plus 5 into 2 plus 6 into 3. Finally the calculations of this is coming 140, calculations of this is coming 14, calculations of this is coming 320, and calculations of this coming 32. So this is my result matrix of these two matrix multiplications, where you can see our result matrix row is coming same as row of first matrix, and result matrix column is coming same as second matrix column count. Okay, that we just learn here. The row count of result matrix is nothing but the first matrix row count, and column count of the result matrix is nothing but second matrix column count. So same thing is coming here, you can see. So row count of first matrix is 2, so you can see the result matrix row count is also 2, and column count of second matrix is 2, so we are also getting the column count of result matrix is 2. So now if you understand the concept and the logic to multiply two matrix and finding out the result matrix, then you are ready to implement that one in Java. So next day we will try to implement the same logic and try to create a matrix multiplication program in Java. But before that, I recommend you use your pen and paper and try to create this type of calculations by your own, so that the understanding will be more accurate and it will not give you any confusion while doing the Java programming. So let's catch in the next class.
I believe this video has helped you to understand about the topic. Thank you for watching. Please do subscribe, click on the bell notifications and select all so that you don't miss any video from this channel.